Good morning, broadcasting across the world, from New Zealand to England to America. We are all on the same day, right about now. And this week we're looking at fractions and percentages. This is session 3. I'd like to take this moment to talk through what we're going to do. We're going to do quantity as a fraction of another. Adding and subtracting, multiplying, dividing, percentage change, compound change, and reverse percentages. If you want to have a go at these questions before the live stream or before you play the live stream from the saved area, please go to Patreon. That's where I'm keeping my stuff. My resources are there, and maybe one day I can fund a website where they can go instead. But there's where they are, and they are free. It's okay watching solutions, but if you have a go first, that's where the magic happens. Okay, so go grab it. And just to remind you all, today is about 82 days away, depending on where you are, where you watch this. 82 days away from the GCSE, okay, the first paper. It's a couple of weeks until the second paper, and then a week till the last. So this is what we're dealing with, 82 days. Check Patreon for some upcoming resources that would be quite useful. It's now the exact time that we are due to start, so let's get going. Question number 1. Okay, so after the summer, a rabbit colony had increased in size from 90 rabbits to 108 rabbits. That's with a double B. It's not a trick question, I assure you. And what fraction has the size of the colony increased by? Now this question is asking what is the increase as a fraction of what it used to be. So in short, we're looking at how much in actual terms it's increased by. So we can see the difference is a subtraction of like so, and it's 18. So it's increased by 18. We want to know what this is as a fraction of where it came from, like of 90. That's quite simple. If you want to know, you write it as 18 over 90 and simplify. So 18 divided by 90 can be simplified, if you're not really sure, divide it by 2 until keep going until you get to the lowest form. But if you want to use a calculator, it will tell you immediately that it's 1/5. This is percentage change in the sense that you're finding one number as a fraction of the other, like an increase of what it is typically find the difference and then divide it by the original number. So that's a 20% increase, but as a fraction, that's 1/5. So be careful on the wording, that's really, I think, what to look out for in this one. And if anyone is here watching right now and you have any questions about this, or you want to share what you thought, then that would be cool. You can put it in the text, in the chat. The thing about it is I can tell a lot about what you don't understand or what you might need based on the question that you ask. It's a professional byproduct of teaching for so long. So please do ask away, and that will lead to good development in different areas. We could extend or challenge or anything like that. Let's move on to the next one. Okay, so your basic question in terms of calculation. Now we're going to try and not do this on a calculator. We have to appreciate how things work before we start using technology to replace us. So you're probably thinking common denominators. We're probably thinking we want to change this to a standard form of fraction. So 1 1/3. See, all these skills have been thrown in here, hopefully to recap them. conversion from a mixed number. We're going to multiply these two and we're going to add those two. Do you remember? I have a video on this. I remember doing this maybe a year ago, but this is in your classrooms, isn't it? Standard. It's a trick. You could think about it in terms of visuals, like how many thirds you've got. So you clearly have 3/3 in a whole and then an extra one on the right there. I think I want to take this moment to add in that 1 1/3 is exactly the same as 1 plus a third. I need that to be very clear. There's a hidden add there if you want it to be. So we're saying we've got 3/3 there, and that's how we write it. 3 is how many we've got, that's the top number. And this is how we've split it, thirds. And then on here we've got 1/3. And like we're about to do, we now have a common denominator and we can add that. Okay, so however you convert it, you should get this. And in order for us to do any operation of addition, we're going to need to get a common denominator. Now 3, 10 and 15 look like they all go into 30. And it makes my life easier, your life easier, if you know your times table. So I just went up in 15s, which was the biggest number, and very quickly got to a number that I could verify the other two go into. So we're going to go with 30. And I like to just write 30 because that's where I'm aiming. And it depends on what we do to get to 30 though. So with the first fraction, the 4/3, we're going to have to multiply by 10. This is my little wee plan here. And how do we know the numerator? We have to do the same. So it's going to be 40. And in here we have to multiply by 3. Do the same on the top. And the bottom times 2. It's always what we do is the same to like on the top, don't forget. And now they're all the same. It just becomes about, now I figured this out last week. I used this highlighter, but I realized the opacity wasn't low enough, so I'm going to turn that down. It's now all about what happens with the numerators. So they're all the same. So this sum is going to simply be out of 30. And we could do the operations on the top. So 40 plus 21, which is 61. And then we're going to subtract 8 from that, which is 53. And you might want to check if you can cancel that down, but in this case, no, you can't. So this is the final answer. Type of fraction, this is top heavy. You could make it even neater. Currently, just take a few seconds and think, do you know how big this is? Like as a number, as a decimal? It's not very obvious, is it? Straight away. So the best form to have it in is one that gives you that sense of how big it is. And that's going to be a mixed number. So we can clearly see that 30 goes into 53 once, a whole time. And then we have a remainder of 23 out of those 30 parts. Now 23 over 30 can't be cancelled down any further, but you can at least now see that it's about 1.6-ish. Like it's maybe 1.7, maybe a bit more, right? And that's because we've changed it to a mixed number. It makes it easier to deal with. So final form of fraction is a mixed number if possible. Okay, because of illness, 2/5 of a school was absent on Monday. Is it were absent? 2/5. So to know what 2/5 looks like, 2/5. Now it becomes less scary. The words are always putting people off. If the school had 650 pupils on the register, how many were absent that day? So 2/5 were absent out of 650. So 2/5 of 650. Here comes a very key skill, is finding the fraction of an amount. Seriously key skill. It's a precursor to a lot. And wherever I see there's a particular difficulty at the higher levels of maths, it comes down often to a lack of understanding of how to deal with multiplying a fraction by a whole number. The first thing to realize is that the of in mathematics means times. This might not be a revelation to a lot of you, and that's great news. And second is that when you have a number, it multiplies the numerator. So I'm just going to be pedantic and write that all out. Okay, so it's going to be 2 times 650 on the top, and then over 5 on the bottom. Okay, so 2 times 650 is 1,300. Still over 5. And if we divide that by 5, we've got 260. However you do it, we're not here to deal with that. We're here to deal with fractions, I suppose. 260 is equal to 2/5. Okay, so you could write equals 2/5, but that's how many are absent. It feels like a really bad day. If $5.20 is 2/3 of 3/4, oh my goodness, hold on. 2/3 of 3/4 of a sum of money. What should we call that? We don't know. It's an unknown amount. Sometimes we give it a letter. We may not need to. What is the total amount of money? So it seems as though something has happened to this sum of money, and then it's equal to this. So there's a couple of ways of looking at it. The way I'm going to look at it is, say, I've got a number. Actually, what should I do here? Yeah, I'll do the 2 ways. I suppose it's not that different. But let's say we start with a number and we multiply it by 2/3. So 2/3 of 3/4. In fact, it would be the other way, wouldn't it? So of 3/4. So we first of all found 3/4 of that number. And then we multiplied it by 2/3. So the key statement in maths is to find, now you get an option box here, a fraction, decimal, or percentage of a number then multiply, say, by that fraction decimal. So I'm going to read this now in the order I want you to read it. I don't know why I'm doing it like this. To find one of these of a number, so find a fraction of a number, multiply by that fraction. It works if it's a decimal or a percentage, whatever. So that's why I'm multiplying by 2/3 to find 2/3. These are little fluences we need. That will be equal to, once I've done that stuff, it'll be equal to 520. So here I'm using algebra. I'm saying here's an unknown amount. I would do something to it, and I would rearrange to find x. The other way, which is I think a little bit more powerful, is to think, excuse me. The other way, which I think is a little bit more powerful, is to think, okay, I'm going to multiply the 3/4 by the 2/3. So what is that? 3/4. So we're going to multiply the 2 tops. This is multiplying fractions, essentially, what we're getting at here, which is 6 over 12, which is a half. So the effect of multiplying by these 2 is a half. So this is what has happened to the original number. So if we've halved it, what you're looking at is that let me write dollars properly, I'm still not used to it. $5.20 is equal to 50%, or alternatively, half. We ask what the original amount was. Well, if this is half, we just double it. We could say that's equal to 1, or in other words, in percentages, it might make more sense. That was 50%, so this is 100%. And just to satisfy this last one, if you were to use algebra. We've got that was a half, and then we would multiply both sides by 2, and then we would get the same. So there's a couple of ways of setting it up depending on how you understand the question, like what's presented to you. All right, lots of good stuff on that page. One of those nights, coughing. Kate's stride is 3/4 of a meter long. How many strides does she take to walk along the deck of a ship, which is 17 1/4 meters long? Now, feel free to have a go at that while I take a drink, and do it however you want. Draw it if you wish. It's a very warm night. That'll give you a clue where I am. Okay, Kate's stride. So how did you do it? Did you decide to draw all of these 3/4 of a meter and see when you get to 17 1/4? Well, there's probably a quick way of doing it, and that's a way that I wanted to do it to test a particular skill. So if this 17 1/4 is the length and her stride is 3/4, we wanted to know how many 3/4 go into that full length. So call it the full length and each stride. That would make sense, wouldn't it? How many of those 3/4 go in would be how many whole steps that they take. So clearly here the thing to be able to do is division of fractions. And we're going to convert it first. We've got 17 times 4 plus 1, which we get 69 over 4, divided by 3/4. Now, nobody wants to do divided fractions. That's why we rely on a very beautiful part of mathematics called the reciprocal. There's a reciprocal relationship. If I scroll down, that says, and it works for so many things, it says 69 over 4. If I want to divide it by 3/4, that would be the same result as multiplying it by the reciprocal of this, which, if you know your reciprocal, you flip it upside down. If it's a fraction, you flip it upside down. And if it's a number, say 3, the reciprocal is 1 over 3. As you can see, 3 is 3 over 1. If that was, if you just said, whoa, just take a moment and have a look at that one again and see what I did. If you still have questions, ask away. So now this question up here, the division, turns into a multiplication, and it's clear why we would do that. It's much easier to deal with multiplications. If you have a calculator, go for it. If you want to make your life a bit easier and you don't have a calculator, you realize that you have this. Okay, so these cancel because they are on the top and the bottom. So what we end up with is, and we'll do this properly. 69 over 4 times 1. And the reason I write 4 times 1 is because people think that the 4 just disappears. And they think, just going to not write anything, like a 0 or something. But what is left after you cancel the 4 is still a 1. 69 over 1 times 1 over 3. Now that does make our life easier, because on the top we have 69 and on the bottom we have 3, and that's 23. So it's actually 23 full strides till we get to the end. Okay, let's do that whole thing again, where we have to scroll back. A computer rig was first sold in a Waitangi Day sale for $985. After this, the price was increased by 23% back to its original price. So without reading too much, let's figure that out. 985 increased by 23%. Well, call that 100%, 985, and we want to add 23% to it. In total, we want 123%. And remember earlier we said if you want to find a percentage of a number, you multiply by that percentage. Now you can do that on a calculator. I find it easier to convert it to a decimal first, which is 1.23. This is what we call a decimal multiplier. And in essence, if you multiply by 1.23, you multiply any number by 1.23, you will increase it by 23%. If you found 23%, like 23%, let's find out what that is real quick. It's 226.55, right? So if you found that and then added it on, so you're going to add 985, that's 2 steps. Takes longer. And every time you find that 23% here, it's going to be a different 23%. Whereas if you rely on using the decimal multiplier, that 1.23 is the same all the time, and it will jump straight to the correct answer. So by multiplying 985 by 1.23, we will find an increase of 23% straight away on the calculator. And yes, this is a calculator sort of topic when it comes to this. If you want to think of one, unless the percentage is so easy that they're expecting you to do decimal multiplication like this, I guess nothing is safe from being on the calculator or the non-calculator. Best of luck figuring that out, but I guess be ready for anything. So this is the first part of the question. Up to here. After a year of not selling, the price was reduced by 20% to encourage sales. How much would this final sale price be? So again, I'm going to talk you through percentage multipliers or decimal multipliers. We're now assuming that this here is 100%. This is our new amount that we're dealing with because it says this price was reduced by 20%. So we want 100, but we've got 100%, and we want to take away 20%, which leaves us, there's a little bit of space, with 80%. So we want to find 80%. So we're going to multiply by 80%. But we don't want to do a calculator. I just divide it by 100. And I say I use a decimal because it's easier to put on a calculator. This is the decimal multiplier to reduce by 20%. Okay, 0.8. Just do that now. 1211.55 multiplied by 0.8. And we get 969.24. And that's where it ended up. So originally it was 985. So it's ended up less than it was before, even though it was reduced by less than it was increased by. A very important concept that we'll explore down here. Show that a 10% decrease followed by a 10% increase is equivalent to a 1% decrease. There's many people, when they first start learning about like percentages, their intuition tells them that this 10% increase and then a 10% decrease, or other way around in this case. Let me just, yeah, that's right. So there's many people that think that this is like a cancels out, that it's back to where it began. The fact of the matter is 10% of one amount, if it's increased, it's going to be like 10% of that new amount is more. Or if it's decreased, 10% of that new amount is less. So you're going to take off 10%, and then you're going to find 10% and add it on. It's slightly less. Anyway, let's see it work out in a couple of ways. Well, in fact, just one way, because this is the sophisticated way of doing it. Now, decimal multipliers make this very quick. What is the decimal multiplier to decrease by 10%? Hopefully you got it, 0.90. I write 0.90 so you could see that it was 90%, but you could write 0.9 as fine. What is a 10% increase? It's 1.10 or 1.1. Okay, so how do we apply that increase? We've got to multiply it. So if we began multiplying by 0.9 and then we multiplied by 1.10, so 0.9 times 1.10, overall, the calculator tells us is 0.99. So by doing that, followed by that, so that followed by that, we end up with an overall effect of 0.99, which if you multiply that by 100, always do a separate line, gives us 99%. Now we started, whenever you start a question, 100%. We did two things to it and it became 99%. That looks like 900. There you go. So the overall effect was 100 take away 99, which is a 1% decrease. So we've shown that that is the overall effect. Let's scroll up first and then change. The depreciation, what does that mean? It means it goes down in value. Let's give people a chance to think first, you know. So it goes down in value. I have an iPhone 15 Pro Max. Anyone got one of them? I know a few people. Pretty good phones. Is fairly good for the buyer in general. So we all know iPhones don't go down in value because they're highly desired. You can buy one for $2,499, and for every year that you own it, it will depreciate by 8%. So in other words, it's going to reduce by 8%. What is this as a decimal multiplier? To reduce something by 8%, we multiply it by 0.92. How much will a person's iPhone 15 Pro Max be worth in 7 years after owning it? Well, we start with 2,499, and after 1 year, it's been reduced by 8%. After 2 years, it's reduced. Well, so after that second year, it's going to be reduced. Whatever this is, it's going to be reduced again, but they're all multipliers, so you don't need to put the brackets, but it just helps to visualize. Whatever this previous result is, it's going to be multiplied by 0.92. After the third year, whatever that result is, by 0.92, do we get it? This was after 1 year, this is after 2 years, this is after 3 years. Seems to be the amount of years is the amount of times we're going to multiply by 0.92. This allows us to use indices. So the original amount there is going to be multiplied by 0.92 7 times. And this is a general form of what we call compound change, compound interest, compound depreciation. You have the original amount multiplied by, and this is interesting, like this is going to be the decimal multiplier of the change, okay? That's like the percentage change effect. And it's to the power of, or the index of the number of years. You could say the period, right? So for example, you could leave it as n, because sometimes that's going to be enforced once every year or once every week or once every day. It doesn't matter, but for our case it's years. So this would be the general formula to have in some sort of revision book. Now we just have to put it in a calculator, and you just be careful that you don't miss anything and use your brackets properly. 0.92 to the power of 7. And once that goes in, you get something lovely. Now, because this is a price, we have to round to 2 decimal places. So it was 0.5, but it's 0.58, and that's dollars. And we will say that we've rounded it. Money is always rounded to 2 decimal places. Okay, this is great, right? This question is a good one. It's usually easier for something that's growing. The depreciation, people mess up on the percentage. But this is how to do it. This second part is a challenge often. So at 1 year old, a plant is 8 centimeters tall. It grows in height by 18% per year. How long would it be until the plant is 11 meters tall? So first of all, we have to appreciate this is a question just like previous. It's compound, because the progress that you make on that percentage increase, it doesn't go away. It stays with the plant. You don't just cut off the growth that happens in that year and then keep going. It stays on the plant and then it builds upon that growth. So the bigger the plant, the faster it grows. So at 1 year old, a plant is 8 centimeters. This will be where it starts. So following the form above, that's the original amount. So this form up here, the original amount is 8, and we're going to multiply it by a decimal multiplier. Now, the decimal multiplier is how much it grows by. It's 18% per year. To increase something by 18%, it's 118%, which if we divide that by 100 is 1.18. 1.18 is great. That goes in there, but when it comes to the, like, how many times you're going to do that, this is the thing that's left in the air. Like, how long? That's the thing we don't know. That's like x in this case, or let's use n because that's often used to represent how many. Until the plant is 11 meters tall. So we want to know what this value is when, so that we get 11. But it's not 11. We have to be very careful here. There's 8 centimeters, and that's 11. There's 100 centimeters in every meter, so that's 1100 centimeters. So in fact, that's 1100. Well spotted, sir. Thank you. So so what we're going to do here is there's a couple of ways of doing it. If you're clever with rearranging, and it does require a little bit of cleverness here, and I'll show you that trick in case you want to remember it, because essentially at your level it's the same every single time. But let's do it the way that a lot of people would be happy to sort of accept at the level you might be doing it. We're going to test values. So we're going to test, let's say n equals 10. So we're going to put that on the calculator ready because we're going to be changing values. 1.18, use brackets to the power of 10. So we're going to put that in and we're going to see what happens. And we might want a little table. So when, let's make it table-ish. And this would be growth. I don't know. Fine. 10. So if it is 10, we get 41 centimeters. So it's not 10. So just press that back button. Usually you'll have some buttons on your calculator that are directional. You're going to press the back button and it'll allow you to edit that equation. And we're going to move along to 10 and change it to 20 because that wasn't much. Okay, 219. So I'm not writing the full length until we get near to it. Remember, we're getting to 1100. Well, that's no good. Maybe we'll try 30. Okay, we've got 1146. That's too much. Let's try 29. This is live with you here. Okay. Can you see the logic here that we've isolated it between 2 points? This we can talk about as too high, and this is too low. So it's in between here and here. Now we're going to say how long until it is 11 meters tall. you could carry on going and say, let's try 30.5. If it's the case that you're told, like, when does it first reach 11, and we only measure it every year, you're going to have to go with 30 because you don't measure it in between. And in fact, if you're going to assume that it has a linear growth, as in it keeps growing by the same amount every day, it's probably too far of an assumption. Things might grow more when they're watered, and if you measure it the day before it was watered, then unfortunately you're not going to get an idea of where it might be the day after it sprouts forward. Anyway, this is extreme, just to talk about modeling assumptions here, but in these cases, this is enough. If you have a calculator, there is a way of using the log button to do this. And the log button, it looks like this. I'll just draw it because... So log... Now you don't need to fully understand this button, but it allows us to rearrange equations like this to isolate powers that are unknown. So we can see that there's an equation here because it's an equals sign, and it's the power that's unknown. This is a good chance to use the log button. So let's just write it again and talk you through how you use it if you fancy. So we want to rearrange. The first thing would be to divide by 8 on both sides, trying to get the n on its own. So 1/100 divided by 8 is 137.5. You could leave it as a fraction at that point, like it doesn't matter, but let's say it's on your calculator now. Using this log button, what we're going to do is essentially get rid of this 1.18 by using this log button. Essentially, we're going to apply logs to both sides. Anyone that's done a little bit of log work, I'll show you perfectly what I'm doing. I'm applying log base 1.18 to this 1.18n. Because you do it to one side, you do it to the other side. 18137.5. Okay, so this all looks very weird. But I'm going to show you that you just need to type one thing in the calculator. This is how it works. Essentially, these will cancel, so we end up with n equals log 1.18, 137.5. So if we get to this point here, and I'll highlight it. Remember, if this is too much, you don't have to listen to this. This is just a little trick, okay? You get to this point and you want to know what that power is, that really elusive, difficult power. All you have to do is use this button here, the log button. Let's use different colors to highlight it. In the little, what will pop up on your screen is these little boxes to fill in. In the box at the bottom, you're going to write the decimal multiplier. And in the box, which color should we use? Purple. And in the box to the right, you're going to write the value over here that you've got when you divided by 8. And if I do that now, so I'm going to type the log button, 1.18, and then 137.5, I'm going to get an exact value. Now, logarithms, if anyone's looking to study A-level maths, and you'll be seeing this in the next year. Some of you, if you're studying further GCSE, will already have seen this, perhaps, or if you're at interest. We used to do these with rulers, but now calculators, really cool. Once you type that in a calculator, it gives you the precise number of n, the exact number of years. Okay, now this is what we thought. It's between 29 and 30, but we didn't know quite precisely when. And it's an assumption because we're not saying this plant grows perfectly the same every day, but if it did, it's 29 years. If we take 29 off of that value and multiply it by 365, we'll get that was 29 years, 272.80036 days. Scroll down even more. Now, if we take 272 off of that and multiply it by, what we're talking in days now, 24 hours, that's going to be 29 years, 272 days, and 19.208 ... hours. Like, you get my, you get where I'm coming from here. We're going to take away 19. Anyway, let's conclude. We probably don't want to go to all of that detail. We might want to pin it down to the number of days. But even that would be too much. The question would likely just have the number of years. And we could say, because it's 29 plus 272, the next marker would be 30. So that's when we would first see it go above 11. And that's all we'd know about it. All right, last question. I received 385 pence or £3.85 back from the tax office, which represents 17.5%. So straight away, I'm going to write down how I understand this question. £3.85 is equal to 17.5%. And this is really, I think this is the most important part of the question. Knowing what percentage the things that you have in front of you are equal to. And then we can work from there. How much did I pay for this equipment in the first place? So this represents 17.5% of the original amount. And technically we want 100%. So there's a really good go between. Especially if you have a calculator. There's other ways of doing it. You know, you could set it up using algebra, but we're just going to do it this way. If we divide by 17.5, what we get is 1%. And you can see how that would be advantageous, hopefully. So 3.85 divided by 17.5 is going to give us 0.22. So just to be clear, you have to divide both sides, okay? And then straightforward, I hope to see, we times that by 100, and we end up with 22. And that's what we're after. What was it originally? That's 100%. So £22. And I think whenever you're tackling difficult percentage problems, knowing what percentage is equal to what is always a very powerful thing. You know, the words can trip you up or make you do strange things. But let's focus on the facts and write them down and work from there. Okay, so that's the end of this morning session. We do aim for around 40 to 50 minutes each time. I don't see any other questions. I haven't received any on Patreon, so that's it for this week. Thanks for showing up. Please do feel free to subscribe for notifications on the next one. So Saturday morning Tonic next week. We're moving on again, and look out on Patreon for the early release of those questions. As I said, really important to do them yourself first, and then either bring your own or see how well you did. Happy to take questions halfway through the week as well. If you want some hints, that's absolutely fine. Have a good week.